We're interested in which algorithms are the fastest. We have seen that quicksort is faster than selection sort, certainly for 8 items like this, but we don't know for certain that it's faster when we get to like 100 items or 1,000, although, spoiler alert, it is actually faster. The thing we can't really do it. This is very time consuming to do it manually. It would be much better if we had a program to do it, and then we could sort 100 or 1,000 or however many items, and it would be really quick and efficient because computers are good at that kind of stuff. So we have a program available. This is the one from the Computer Science Field Guide. It's also on Google Classroom. Called Selection Quicksort Python 3.py because it's a Python program. If we double click it, it doesn't. Well, it does work, it works perfectly, but it actually runs and then closes the window it's running in, which is no good to us. We need to actually open it and edit it. So if you right click and edit with idle, it opens up in this editing environment and we can see the actual program itself. You're not expected to understand the fine detail of how this program works, but it's reasonably, you can look at it and you can make some reasonable sense of it. For instance, you can see that these functions have been defined. This is the selection sort and it works on a list that you give it, and you might be able to work out what's going on in here because it's quite well written, it's quite easy to follow. And there's a quicksort program as well, but that is a little bit more complex because it keeps breaking out into different functions, this partial list and partition and so on. So that's quite hard to understand. We can modify this, of course, and we can change things around. We'll look at that in a moment. If I scroll right to the very bottom, we'll see the bit of the program that actually runs. All these functions are defined at the beginning, but this is the program that actually runs. And as you can see, it calls a couple of functions. It calls a function called test selection sort, and it calls a function called test quicksort. These functions are up here somewhere, test selection sort and test quicksort. And basically all that these do is they actually time how long it takes to do a selection sort or how long it takes to do a quicksort, and then gives us an output of that. So if I run this, I can do this by going to the Run menu and Run module, or just pressing F5, and it runs them. And let's just have a quick look at the output. In this case it says 10 keys. Keys just means 10 things that it sorted, 10 numbers that it sorted. And it said for 10 things it took 45 comparisons using selection sort, which took 0.03 milliseconds. So that's 0.03 thousandths of a second. That's pretty quick. It also quick sorted those, and it wasn't much quicker. It was 0.030 instead of 0.031. It took 25 comparisons. So that is telling us that for 10 keys, quicksort is a little bit faster. It also did 20 and 50 and 100 and 1,000. So let's look at the 1,000, skip ahead. And it says that for 1,000 things that it sorted, 1,000 numbers that it sorted, it was about 500,000, 499,500 comparisons made using selection sort, which took 148 milliseconds. So that's still less than a fifth of a second, but it's relatively slow in computing terms. Whereas quicksort this time was way faster. It took 3 milliseconds and only 11,000 compared to 50,000. So what we're seeing there is that as the number of things we're sorting increases, quicksort becomes way better than selection sort. It's good to begin with, but the more things you're sorting, the better it is compared to selection sort. Now let's just have a quick look at the stuff in this program that actually ran it, and we can just inspect this. So you see how it did 10, 20, 50, 100, 1,000. These are these numbers here. Okay, so you can modify these and you can say, oh, I don't need to do the 10, 20, 50, 1,000. Or you might choose to say, oh, I'm going to do some numbers which can go into a graphs. So I'm going to do 10, 20, 30, 40, etc. And work with something that, because otherwise you're going to get an uneven scale and it will be a misleading graph. We don't want that. And it does do for repeated experiments, so we could say do it, say, 5 times. Oops, 5 times. And if I save that and run that again, we should see how that affects what we do. So it runs in the same window. Oh, gosh, it was quite a lot of things that it ran that time. So you can see, yeah, so it did say 20 keys, 1, 2, yeah, 5 times. Right. Now, the last modification that you're likely to make is that all of this is very verbose. There's a lot of words in there. And it might well be helpful to not bother with all of these print statements. So, for example, this one doesn't actually run anyway, but here it says for selection sort of n keys, comparisons made, blah, blah, blah. So we can just delete that, for instance, and we can just put n comma comparisons made, and we just know what happened. And maybe we won't want to know the time taken, we'll just work with that. So that's just for selection sort, and then for testing quicksort we can do exactly the same thing. Take out the time taken, take out that, and don't need that, and I don't need any of that. Maybe let's just save that. I'm going to take that. I don't want it to run 5 times because that just made a lot of mess. So save that and F5 to run it. Oh, that's nicer. Selection sort, and I could take out this line if I wanted to. And these are numbers. If you're really clever, you could do the output in such a way you can paste it directly into a spreadsheet and graph it. And yeah, that'd be impressive, eh? So I think that's enough of a starter for you to understand how to use and run this program.